So this is a practice video for practicing probability tree diagrams and also interpreting Venn diagrams in terms of probability. So we start by drawing our Venn diagrams. So this is the outside of our Venn diagram, the universal set. And inside we draw two overlapping rings. So if you want to pause the video and follow along with this video, so pause it at this stage, draw your Venn diagrams, and then what we're going to do next is draw a probability tree. So each one of these will get a probability tree diagram representing two events and branching as tree diagrams do. Okay, now we're going to fill in some numbers. Now you could come up with your own numbers. All you need to do is think of some likely fractions and then combine them together and fill in the tree diagram. So you could develop your own exercises, but for the purpose of this video, let's start with these numbers like this. So we'll start with 8 and 3 and 12 and 2. And this is event A and this is event B, obviously. Okay, so we're going to interpret this diagram and fill in the tree. Our second one, let's have 15, 20, 8 and 6. Again, A and B. Then we'll have 6 in the middle, 15 then, 10 and 25 the outside, A and B, and finally we'll have 12 in the middle, 28, 21 and 49. So if you already understand how to do this video, then pause it now and give each of those a go. If not, let me work through problem A for you, and then having learnt how to do this for problem A, you can then again pause the video when you want and have a go yourself. Okay, so the very first thing we're going to do is add all these up. So for problem A, we've got 8, 12, 3 and 2, and so this is going to be out of 25. So if I just draw 25 here. And the aim of this is to find out what the probability of A is, the probability of B, and do a little bit of calculations on those. So the probability of A we can get from our diagram here is 8 plus 12, which is 20 out of 25. So 20 out of 25 simplifies to 4 fifths. 4 fifths. So I'm going to fill in my tree diagram now on this branch. So the likelihood of event A happening must be 4 fifths. Okay, so the likelihood of event A not happening must be therefore 1/5, because 4 fifths and 1/5 adds up to 1. Okay, what about my second branch then? Probability then of B, event B happening. Well, event B, I can read off from here, is going to be 12 add 3, that's 15 out of 25. 15 out of 25. And so we can simplify this to 3 fifths. 3 fifths, so just simplifying fractions. So probability of B must be 3/5, and that makes sense, 4/5 and 3/5. This branch here then, because these two branches must add up to 1, has got to be 2/5, and I'm going to assume independent probability, so these numbers will be the same. Okay, so finally, probability of, nearly finally, probability of A and B occurring. Okay, if you know how to do that, pause the video and give that one a go. So, to get that, I just need to go back to my Venn diagram here. It's this number in the middle, and the answer is 12 out of 25. And what I could have done, and a good way of checking, is I can multiply these two branches here on my probability tree diagram. So I get 4/5 times 3/5, and I should get the same result. 4 times 3 is 12 25. Okay. Lastly, probability of A union B. Probability of A union B. What would that be? So it's 8 add 12, that's 20. Add 3 is 23, so that's 23/25. So A or B is 23/25. That makes sense because my diagram also says that there's 2 out of 25th chance that neither A nor B will happen. And just to finish this one, 12 out of 25th, if I check on my calculator, convert it to a percent, would be 48%. And that's problem A complete. Okay, problem B. Pause the video if you understand what to do and give it a go. Okay, so probability of A. Well, probability of A is, for my Venn diagram, 35 out of 49. 35 out of 49. And that will simplify, sorry, let's neaten that up. Both divide by 7, both are multiples of 7, so that's 5/7. So my first branch here has got to be 5/7, which means this branch must be 2/7. Okay, probability of B. Probability of B is 20 plus 8. I didn't total this, did I? This is 49. This adds up to 49. So probability of B is, what did I say, 28 out of 49. And that's, whoops, and that simplifies to 4/7. So that gives me my second branch, 4/7, and that means this must be 3/7, and assuming independent probability, the numbers are going to be the same on these branches here. So that completes the tree diagram. Now I can multiply this branch and this branch, these ones here, 5/7 then times 4/7 will give me the probability of A intersect B. I was going to write that underneath. Let's write that underneath. Okay, probability of A, B. So 5/7 and 4/7, that's 5 times 4 is 20, 49 then. And that won't simplify. So going to my diagram, let's just check. I've got 20 out of 49, so that's confirmed by the Venn diagram. 20 out of 49. Probability of A or B, just adjust that. Well, you just go back to the Venn diagram. 15 add 20 is 35, plus 8 is 43. So 43 out of 49. And if I want a percentage on, I'll only do one of these, A and B, that would be, what would that be? 41%. You might want to do these. What would that be? And what would that be? And that completes problem B. Okay, problem C then. So, if you know what to do, pause the video, give it a go, and follow the worked solution, see if you're right. So, probability of A, 15 add 6 is 21. 21/56. And that simplifies, both divide by 7, so both are multiples of 7, so 3/8. So 3/8. So that's my first branch, 3/8. So my second branch here, my not branch, must be 5/8. Probability of B then. So 6 add 10 is 16. And we haven't totaled it yet, have we? It's 56. 21, 31, 56. So put a total here. So 16 out of 56. And 16 out of 56 simplifies to 2/7. So 2/7 on my event B, therefore 5/7 on my not branch there. So 2/7 and 5/7. Okay, so probability of A and B occurring is what? So I just need to multiply these together. So I've got 2/8 times 2/7 gives me 4/56. So something's gone wrong. That should be 3, shouldn't it? Whoops, 3. Anyway, not 4, 5/56. Yeah. 5/56. Let's just tidy that up. Okay, I'm going back to my diagram. Does that make sense? No, it's not right. So something still wrong with that. Yeah, 3 times 2 is 6. Of course. Okay. So 656. Okay, and 656 is going to be 3/28. And if I do the percentage now, let me see, 11%. Okay, finally, so 3/28 there. Finally, probability of A or B. What's that going to be? So it's going to be 31/56. 31/56. And if I look at the probability of that, that's going to be 55%. Okay? So finally, problem D. And if you haven't paused the video up to now, or even if you have, time to pause it and give it a go. Okay, so probability of A. Well, that's going to be 40 out of whatever the total is here. So let's just add these up. 110. So it's 40 out of 110, which is 4/11. So 4/11. This branch then must be 7/11. Okay, probability of B. Well, probability of B must be 12 add 21, so that's 33 out of 110. Both are multiples of 11, so that's 3/10. So 3/10 on this branch, and on this branch 7/10. Assuming independent probability, the numbers must be the same here. Okay. So to get my probability of A and B, all I've got to do is multiply these together. So 4, it's this branch and this branch, 4/11 times 3/10. Well, that gives me 12 over 110. So 12 out of 110 possibilities, and that's confirmed on my Venn diagram here. 12 out of 110, and 12 out of 110 turns out to be 11%. So, and that would simplify down, actually, wouldn't it, as 6/55. Okay, finally, probability of A union B, or A or B. So chances of A or B happening. Well, 28 add 12 is going to be 30. 40 add 21 gives me 61 out of 110. And again, if I do the percentage on this, 61 out of 110 gives me 55%. So 55%. Okay, well, I hope you enjoyed that run through and following those calculations with me, and hopefully it made you more practiced